Good evening, everybody. We will discuss a problem. Yes, I will show. I think my screen is visible. So here I have taken a problem. It is a problem which is taken from gear trains. And now we will see how to solve this problem. Here we are given with in a reverted T-cyclic gear train. The arm A carries two gears B and C and a compound gear DE. And the meshing is given. Here gear B it is meshed with gear E and gear C is meshed with gear B. The number of teeth given, so that I am writing here, number of teeth TB that is 75 and TC that is 30, TD that is given 90. Actually here we are having four gates TCDE and TE number of teeth on gate E is not given. That we can find out. Based on this machine, I can write a relation in terms of diameters. Here, gear B meshed with gear B. So I can write the diameter of B plus diameter of E that is equal to diameter of C plus diameter of D. C is meshed with 30. That I can transfer it to the number of teeth. TB plus TE is equal to TC plus TD. So this is TB 75 plus TE that we are going to determine is equal to TC that is 30 plus 90, not degree. This is 90. So from this I can find out that TE is equal to 90 plus 30, 120 minus 75. That is equal to 120 minus 75, 45. 45 number of teeth. 45 number of teeth. So now we know the number of teeth on all the gears, gear B, C, D, and E. And what is given? Find the speed and direction of gear C. NC. You are asked to find out what is the speed of gear C and the direction also. Direction means it is rotating whether in clockwise direction or in anti-clockwise direction. That we are going to find out. And the conditions are given here. Conditions gear B is a fixed. This is one condition. Gear B is fixed. Fixed. It means N B. Oh, sorry, okay. Let us discuss later. This is one condition. Gear B is fixed. Another condition also given. The arm A makes 100 RPM clockwise. Arm A, that is NA, is equal to 100 RPM clockwise. So these are the two conditions given. Based on these two conditions, we are asked to find out what is speed of gear C and the direction. So for this, what we do is we have to form a table. We are going to solve this problem by using tabular method. But the table will be by default. We have to take like this: step number, and conditions of motion. Conditions of motion. Next, revolutions of elements. So we have elements here arm A. Next, compound gear, DE. Next, gear B. Next, gear C. These are the revolutions of elements. Like this, we have to form the table. So from this, first I will take step number one. conditions of motion I have to write. Arm fixed, arm fixed, and the compound compound gear, here D, rotates through +1 revolution. +1 means here I am considering plus positive sign for anti-clockwise direction, negative sign for clockwise direction. By default, I am doing like this. This is a sign for direction I am taking. Right. It means here I have written arm fixed means arm 0. Next, compound gear DE rotates through +1 revolution, +1 anti-clockwise. When DE rotates, this one DE rotates +1 revolution, immediately gear B, this is gear B, is in mesh with gear E. We can observe here gear B is in mesh with gear. When DE rotates through +1 revolution, what is the revolution of gear B? What is the revolution of gear B? That we can find out like this. For example, here assume two gears are there. Gear A, assume this is a gear. So I can write a relation, speed ratio, that is NA by NB. Speed of gear A by speed of gear B is equal to, this is inversely proportional to its number of feet, that is TD by TA. NA by NB is equal to TD by TA. For example, if NA rotates through +1 revolution, it means if this is 1, if I substitute, then NB is equal to TA by TD. So from this, if A, this is A, rotates through +1 revolution, the rotation of B will be, the number of teeth on its mating gear, that is TA by TB with a negative direction. For example, if it is rotating in anti-clockwise direction, then B will rotate in clockwise direction. So from this I can conclude that if two gears are in mesh like this, if the speed of gear A is +1 revolution, then the speed of gear B NB is equal to number of teeth on its mating gear, that is TA, by number of teeth on this gear TB with a negative sign. Similarly, I can write here compound gear DE, it is rotating +1. Then DE is immediately meshed with gear B. So now I want gear B. What is the revolution of gear B? Here gear B I have taken. So for this gear B is meshed with gear E. B is meshed with gear E. So it means this is a TE by TB. I can write TE by TB with a negative sign. Similarly, gear C. Here C, this is meshed with a D. C is meshed with a D. So the revolutions of C, it is I can write TD by TC with a negative sign. So with this, step number 1 is over. If you could able to understand step number 1, then we can easily write the remaining 3 steps. Total, this table contains 4 steps. So that step number 2 it is that we are generalizing. Here I have taken arm fixed and compound gear DE rotates to +1 revolution. Similarly, instead of +1, I will take some X revolution. Remaining say arm fixed and compound gear D rotates through plus x revolution. Instead of 1, I am taking plus x. So arm fixed means 0, compound gear plus x. Now gear B, that is minus x into TE by TB. Similarly here, minus x into TD by TC. This is step number 2. Step number 2. Next step number 3, that is yard plus y revolutions to all elements. To all elements. It means here plus y, here also plus y, and plus y. Now, last step, that is total motion. Total motion. Now I am summing up here plus y and compound gear D x plus y, x plus y, gear B, that is y minus x into TE by TB, and for gear C, that is y minus x into TD by TC. So now I formed the table with 4 steps. Now let us see how to solve this problem. To solve this problem, first I am erasing this. What I will do, I will consider the conditions given. So what are the conditions given? If we see the first condition, here gear B is fixed, that is given. Gear B, that was fixed. Gear B, when the gear B is fixed means I have to go for the total motion of gear B. Here we see this is gear B. This is the gear B. The total of motion of gear B, that is this one, y minus x into TE by TB. That is equal to 0. Fixed means 0. That is condition number 1. And condition number 2, arm A makes 100 RPM clockwise. It means I have to go for A, arm A. Here this is arm A. This is arm A. It is making the total motion of arm A, that is y. So y is equal to 100 RPM. Clockwise I have taken negative. If it is anti-clockwise, positive, clockwise, negative. So y is equal to minus 100. So from this I can find out x by minus 100 minus x, I have to find out into TE, number of teeth TE, that we find out, I think this is 45 by TB, TB, that is 75. It's equal to 0. From this, minus 100 minus x into that 45, 45 by 100, we will calculate how much it is. 45 by 100, 45 by, I think it is 45 by 75. 45 by 75. That is 0.6. So, 0.6 equal to 0. From this, uh, minus x into 0.6 is equal to 100. X is equal to minus 100 by 0.6. Let us see how much it is. 100 by 0.6. That is 166.67. 166.67 minus 166.67. Now I came to know x value minus 166.67 and y value minus 100. Now I am asked to find out NC. So NC means we have to see what is gears, where this is gears. The total motion of gear C is this one. This I have to consider as NC. So from this NC is equal to y minus x into TD by T. That is equal to y. That is minus 100 minus x. X already minus plus 166.67 into TD, that is 90 by TC, I think 30. If I calculate, then I will get NC value. So now let us see. This is a 90 by 30 into 166.67 that we will calculate. 90 by 30. 90 by 30 into 166. Yes. 90 by 33 into 166.67. 67. This value. This is 500 approximately minus 100. That is 400. 400. So it means you can take this value. This is plus 400. Plus 400 RPM. It means the speed of gear C, that is 400 RPM, the anti-clockwise direction, because it is positive. Anti-clockwise direction. This is the answer. Thank you.